Uh, this is me. I'm presenting here about sketch to abstract act, and this is my final project for data science capstone presented by Week4. So I am following my presentation. So here, so now introduction of my project. I attempted to develop a model that generates the abstract act from raw sketches. At first, I collected a number of abstract art images and pre-processed it to generate sketches like images using edge detection techniques. And I used the deep learning model then by training these sketches like images so as to generate the abstract images using image to image models. Now my objective for this project was to develop an unsupervised model for converting pencil sketches to abstract art to generate an image to image dataset and train a CNN model. So as you can see, how do we do the art image data extraction? We first extracted the Deluni dataset consisting of 11,503 samples of abstract images from 53 different artists. These are the targeted images that our model should attempt to generate. Generating dataset now. How to sketch to art? As for generating the sketched images, our initial attempt follows a pipelined image transformation. First, we convert the image to monochrome. Converting to image to monochrome means we are converting the images to the grayscale, and we are inverting the image bitwise. Inverting the image bitwise means that we are converting the image from black to white and white to black, and applying the Gaussian blur, as there are many transformation you can apply, but we used Gaussian blur. And now we did bitwise invert again, and after that final we did image division operation. For that, as you can see, image division operation means that in here the image division operator normally takes two images as input and produces a third, whose pixel values are just the pixel values of first image divided by corresponding pixel values of the second. So after that, you can see over here our input images and our target images. So now, how did we model it? We first created a model that was used as an approach similar to Howard decaptification super resolution model for image to image training. It is based on Johnson's alternative to GANS that uses a loss network pre-trained for image classification model to define perceptual loss, and loss function that measure perceptual difference in content and transformed images. This loss function compares structure-wise image features ranging from low-level features in early layers to complex structures in the later layers of pre-trained image classification model. We used VGG 16, and to explain about the model, I would like to explain. We first take the input images and transform it into image transform net, which is used as an encoder or decoder, and this is our transformed image, and it is compared with our this previous image. Our input image is always grayscale image, which we compare with our colorful image, and like this we send to our VGG model in neural networks, and our output is this YC over here, you can see. So like this our networks works. It goes deeper and deeper into identifying the more complex. Let's say for example we have an image. For example, let's say we have an image over here, image over here. Let's say we have an image over here, and this is our image. For example, let's say this blue ground truth is our image. Then it will first detect the simple white line, and slowly the deeper it goes into the neural network, it identifies even the smallest thing. So this is how our VGG works. And now for our architecture details, There are 34 layers, including ResNet plus upsampling layers. Total, there are 95 layers. And dataset, I already explained that we are using delivery dataset. And batch size is 16. And activation function is our ReLU. And learning rate is 1e minus 3 is one cycle learning rate. And optimizer is add and regularizer is batch norm. Loss function is perceptual, is a feature loss. And number of trainer parameters are 41,221,268. So now this is the training logs and other graphs. This image shows the training and validation loss, 10 epochs of training, and this shows the other training logistic as for learning rate and momentum. We use one cycle policy for an automated hyperparameter tuning as suggested by Smith and Toppin at 2017. So now these are the examples I'm showing you from my project. This is the input and this is the target and this is the prediction we do. So lastly, I like to say thank you, and I'm going to demonstrate my project. So here you can see my project which I have done. So first, this 1db, as I explained earlier, I showed you the graph of training loss where we show that training loss and validation loss, and this library. By importing this library, we can see those graphs. So going forward, as you can see, I have already taken the output of my program. It is downloading, and now moving on forward. Now next is we imported the fast AI. This is our fast AI is a deep learning library which provides practitioners with high level components that can quickly and easily provide state of art results in our project. And now after importing it, we see here we are creating the virtual environment for it, and we are loading the GPU file, and now we are installing the fast AI, and we are importing the content from fast AI after installing fast AI here. And this cell is hidden. Oh sorry, I cannot. So now moving forward, we can see these are our data sets. We loaded delivery data sets, and now these X and Y file names, these are X and Y file names, and we can see we used here image resizer to transform it, and lastly through the transformation we can see these are our data images from our data set which we are working on, and we created the model. After creating the model, we are here now training the model, and here measuring the losses over here after training it. And from your summary we can see that our max pooling, our convolutional is 2D, and batch norm 2D, batch normalizers. And after that we are learning and we are finding the graphs. This is the graph of learning rate, and now after we are fitting the graph, and we are saving here, and we are changing the models file and showing the results. This is the input, this is the target, and this is the prediction as we can see here. And now showing the results, we can see that we send the input this and we targeted this, and this is the our prediction. And now we are finishing the library. And lastly, thank you for seeing my projects.